Okay, so the quiz for today is simply add these two fractions. Add the fractions here, add the fractions. Okay, everybody in class did great. Okay, didn't check every detail of the work, but everybody did what they were supposed to do. Of course, I'm not going to say what that is, because for your distance students, you need to take this quiz without any reference to anything and send me a copy. Okay, if you're not sure exactly what that means, email me. I'll be glad to clarify it. And also, one thing I mentioned to the class was I'm always a little concerned on the first assignment that people could just use their calculators to get the right answers on the homework involved with fractions and stuff. And I didn't see any evidence of that in the class. And if you did that as a distance student, you better go back and do the problems and really do them, because you have a test. That's what you're going to have to do. If you use the calculator, well, if you use the calculator and you already know how to do it, you know how to do it. I can't police that. I wouldn't police that. Test results are what are going to police how you do your homework. Okay. And the test results really determine whether you pass this course or not. Okay. So now for distance student, I'm done talking to you. I'm going to go ahead and solve these, so you should shut off the video and do them. Okay. And then you can tune in the video and make sure you did it right. And I think do that, even if you understand how to do it. I want to show you how I really need to see you write it out so that it'll work for you when you have to do it in much more complicated situations. Okay. So okay, pretty obvious that your common denominator is 16, right? So I'll just make myself a little note of common denominator 16. So that means you're going to do 5/8 multiplied by 2/2. Now, some people want to do 5 times 2, 8 times 2. That's perfectly legal, but you really would be better off later on if you would write it this way. Of course, you completely understand that. I wouldn't penalize it. Okay. But as far as extending to what you do with more complicated problems, you want to do that. If you didn't write that stuff out and did it in your head, that's great. I know you know how to do it, but that's how you need to write things out. Okay. Show all the steps. That's just a general thing that we need to do in this course. Show me what you're thinking. Okay. Because you're thinking it's okay to do 5 times 2, 8 times 2 up here. Yeah, for these questions, it certainly is. Okay, so it's not a matter of do it my way versus your way. Your way might get the right answer, but it might not build to something else you don't know anything about yet. Okay, so I really hate it when I don't do anything about it, but I hate it when I hear students that I don't want to do it your way, I want to do it my way, or they don't exactly say that way, but that's they're really saying. Okay, if you do it my way, I think you're much more likely to build an understanding that you will take into more complicated problems than if you do it your way, which is just punching in the calculator. No, that's no way at all. Okay, so write things out in a very coherent form where you have one step, another step, another step, another step. If you're doing some side calculations like finding the common denominator and stuff, somebody wants this pretty good procedure with prime factorizations and stuff on that. Okay, do that off to the side so we don't complicate this, but we can still see what it is. That also has the advantage that if you happen to be reviewing for a test, and you should be doing your homework in a notebook, okay, not scattered here and there, in a dedicated notebook, so that you can review it when it comes to your test. Another comment I'll make in this course is I see a lot of people who do okay on the homework and do okay in class, and never prepare for the test and forget everything and fail the test, even though with a few hours of review, they probably could have made 100 on the test, okay? I see that all the time. People don't seem to understand that you have to prepare for a test. I might be talking to the wrong people here and the wrong people out there. Everybody maybe understands that, but it seems to me that especially since COVID, people don't seem to get that, okay? So I don't know what's changed, but COVID changed a lot of things in education, and that might be the reason, okay? It might just be that our culture is spiraling downward into complete stupidity. Okay, so anyhow, 5 times 2 is 10, 8 times 2 is 16. You add that to 3/16. And how do you add that? Well, the rule is if you got the same denominator, you add the numerators. Why is that? How many 16ths do you have here? You got 10 of them. How many 16ths do you have here? You got 3 of them. If you got 10 of something and 3 of something, how many of that something do you have? 9 of them. And that tells you that you add the numerator and you don't add the denominators. You still got 16ths. Okay? So it's kind of important to understand that and be real clear on it. It's not just rule, it's common sense. Okay? And sometimes you have a rule that goes a little beyond common sense. Okay? Nobody has enough common sense to understand some of these rules. Okay? I'm talking about advanced quantum mechanics and general relativity. There might be a few people in the world who have enough intuition and common sense to understand it at that level. There are a lot of people who can do it, really understand it. And of course, we're not going to get very deep into advanced quantum mechanics and general relativity in this course. Okay, so I'm just using that as an extreme example of things that nobody really has a really good grasp. Okay, okay, and advanced mathematical research, all that stuff. Okay, so anyhow, there we have it. Okay, now I'll do this one over here. Just I don't think I have much room in the line. The common denominator here is easy. It's going to be 7 times 3, which is 21. Now 16 was so obvious that I didn't bother doing anything with prime factorization, but I could have. Okay, and you have to know how to do that if you get a big ugly fraction. And there might be a big ugly fraction in the test. Okay, so there we have it. Here's your common denominator. So it's 7 times 3. So I'd have to multiply the 7 times 3 into 3 times 7. So we're going to do 2 7s times 3 over 3 plus 5/3 times 7 over 7. And that's going to give us 6 over 21 plus 35 over 21, which is 41 over 21. Okay. And I think these are the answers I saw. And I didn't really look at the answers. I looked at the process. Okay. Process every time looked good. You found a common denominator. Yeah. And I think everybody probably got it right. Okay. Now, if your distant student didn't get that right, maybe because you took the easy way out and used a calculator. I don't see a lot of evidence that many people did that, but I don't know. And I always get surprised by people that make hundreds of all their homework and make 12s on the test. Okay. So I'm really wanting to make sure everybody understands what it takes to learn this stuff. Okay. Now we're going to go on to some other topics because this is just kind of a warm up. Okay. Now, I will note that some people are already a little behind on the assignments. And I'm going to have to go to the half credit page. I believe that has the information on Canvas. If you read what's on Canvas thoroughly and don't find it, you can email me and I'll send you the codes. But I want you to tell me what you looked at on Canvas and where you didn't find it. Okay? In other words, read the stuff. Don't ask me to tell you what you read. Okay? If you read it and didn't see it, it's possible. You know, clarify it for you, but you know, do what you need to do. It's not that I don't want to take the time to help you. It's that I want you to understand you got to read things and do things. Okay. Okay, so. Order of operations, I think we did that in the quiz last time. But let's just be sure. I'm gonna have everybody do one. Okay. Go ahead and write that out and work it out. And if you're a distance student, you should take a minute to do that and then I'll work through it. Okay, now, first thing we need to do is write this out in standard notation. Going one step at a time. 3 is raised to the second power. The 2 is not multiplied by 5 because you do the exponent first. Okay, so you write it out like this, which then 9 times 5 minus 1, and we can multiply. Well, I'm going to leave the multiplication. Okay, so we've done the exponentiation. Now we're going to do multiplications, which gives us 45 minus 1 plus 8, which gives us then 44 plus 8 is 50. All right. Okay. Now, I want to move on into something else, and everybody appears to be doing really well right now. We might have even done some of this last time. I was wanting to look at what we did last time, and I kind of screwed up on it. So I wasn't able to locate it. But anyhow, try solving a few equations. 5x plus 2 equals 14. Okay, let's just see if everybody can solve these, and then I'm going to throw one at you. It's kind of a curveball. And that third one, there's something that makes this a very simple problem. And you don't have to deal with fractions. So if you figure out what that is, but if you can't, and most people won't at this stage, okay? Because I have very hard time convincing people what they need to do when they see something like this. So we're going to try to convince you now so you don't stumble up the way. Okay, so that was a little bit of a curveball. I expect everybody can probably do these, but let's just make sure. Okay. Okay. So, yeah, okay, at this point, we're running into problems, okay? Most people, not too much, just little details, and maybe some people aren't using much of anything. But nobody really got to this one. So we'll concentrate on these two. I'm gonna say a little bit about this one. So you got 5x plus 2 equals 14. And now we're trying to solve for x. And there are two things we can do. Now, there are actually a bunch of things we can do, but two things we can do from here. We can add or subtract same quantity on both sides. Okay? Or we can multiply or divide both sides by the same quantity. So what are we going to do? Well, we're trying to find x, and we've got a 5x plus 2. We don't want that 2 to be there, and we don't want that 5 to be there. Okay? Now, the easiest thing to get rid of, and the first thing we want to get rid of, is the 2. We don't want 2 to be there anymore. So what we do is we take the equation minus 2 equals minus 2. This is a true equation, always, right? Can't be false, because both sides say exactly the same thing. Now, this is variable. You know, the value of this side of the equation depends on x. We want to find the x. It makes everything true. But if we assume this is true and this is true, then if we add this to this, we've got to get the same thing as if we add this to this. Okay? If these two are equal and these two are equal, if we add equals here to the same equals over here, we get the same thing. So we add those and we get 5x equals 12. Because, of course, 2 and minus 2 gives us 0. So you don't have to write down the 0. Okay. Now we got 5x equals 12, and we want to find x. This means we're going to have to divide both sides by 5. Because that's how we can get rid of the 5. If we do this, five x divided by 5 equals 12 divided by 5. Then 5x divided by 5 just gives us x. Now, I'm going to off to the side show you in detail why that gives us x. But the basic thing is 5 divides 5 gives you 1. So you got 1x, which is just x. Okay? And of course, then you got 12/5. That suffices for an answer. Now, of course, you know, having done the fractions and obviously done quite well with that, you know that you could write that as 2 2/5, which would be handy if you wanted to locate it on a number line. Okay. So it'd be between 2 and 3, it'd be 2 2/5. Then you could at least estimate where that is on a number line. So there is a use for mixed numbers. But for the most part, we don't talk about them much. Don't use them much, except for that one purpose. Okay. Now, why is 5x over 5? Why does this equal this x? You can say, well, the 5 divides 5 and so forth. Yeah, but that's not really as detailed as would be good to understand it. Because there are mistakes you can make that you won't make if you understand what I'm going to show you. Not many. You probably do okay if you don't understand this, but I think you're more likely to do better if you do. Okay, so, well, five x over 5 equals 5 times 5 over 5 times x over 1. Right? Because how do you multiply fractions? You multiply the numerators and you multiply the denominators. Okay? Multiplication of fractions is much simpler than addition. You don't have to find a common denominator, you just kind of multiply. Now, the reason I chose to do addition of fractions before multiplication of fractions is because once people learn to multiply fractions, then they just want to add the numerators and add the denominators, which is ridiculous, but it looks right. Okay, if you're used to looking at multiplication. So And we did addition first, we do multiplication next. Okay, so you would agree, if I multiply 5 times x, I get 5x, right? So the numerators are equal, and if I multiply 5 times 1, I get 5, so the denominators are equal. Okay? And of course, this equals 1 times x over 1, right? And what do you get if you divide x by 1? You get x, right? So you can say, okay, well, that's just 1 times x. Because anything you divide by 1, you get that thing. And 1 times x, well, you multiply 1 by any number, and you're going to get that number, right? So multiplying or dividing by 1 doesn't change the number at all, and you get x. So that's why you can do this. Now, open math will probably tell you can do this. I really hate that. I didn't used to hate it because I understood it. But I find that students don't understand it and they just do it indiscriminately. And, you know, some people would have this thing in front of them. So, oh, wait a minute, I can cancel this 5 with this 52, the 5 and the 52. And end up with 2 here. Okay. You know, people cancel in a don't cancel without thinking about whether you're following the rules for cancellation. Okay. Open math will tell you the rules, and then I'll talk more about it if I see some bad cancellations. Okay. Okay. Now, basic idea though. Solve this problem. We subtract 2 from both sides, so all we have on this side is x's, right? And once we have just a single multiple of x here, we can divide by that coefficient on both sides and get the right answer. And then we check it. That's probably a better place to put this. Outside my fuck. Okay. So I kind of do it this way. I take this and I plug it in for x. And then I take the equation I get, which is 5 times 12 fifths plus 2 equals 14. In other words, I've taken my solution, or at least what I think is my solution, and I've replaced x by that number, and this is what I've got. Okay. So then what do I have? Well, this 5 divides this 5. Now I could write 5 times 12 over 5 equals 5 over 1 times 12 over 5, which is the same as 5 over 5 times 12 over 1. So by doing this sort of thing, I can get that 5 to be divided by the 5 and then multiplied by 12, which will give me 1 times 12, which gives me 12. So all I'm saying is these 5s divide out. A 5 in the denominator will divide a 5 in the numerator. We end up with 12 plus 2 equals 14. 14 equals 14. Now, put a check mark there because we just checked our solution. Now, when you're doing the homework, it takes longer to check your solution. If you happen to be getting the solution right every time, then you probably don't need to do too much checking, but still do it at least every once in a while. Like on a problem you think you got right, you're not totally sure of, check it yourself. Don't wait for open math to tell you you made a mistake and take a couple tenth of a point off, okay? Check it. Not on every problem, but on the problems you're not totally confident of, because you learn more if you check and then go back and discover your mistake. Open math isn't going to tell you what mistake you made. Just tell you, no, that's wrong, try again. Open math screws up sometimes. Not too much in this course. And the pre-calculus support course, a lot of people take after they get through this one. I just reviewed an assignment where 4 of the problems are improperly graded. I can't fix open math. I could. I just don't have time to go in and redo somebody's program. Okay, take a while to sort out that can of worms. So I just let them stand, and usually I try to warn people. So all I'm saying is, open math isn't always right, but it's 99.9% of the time right for the problems in this course. I think. Could be that those same problems occur later in this course. Try to warn you if they do. Okay, it's a digression, ignore it. Open math will tell you accurately in most cases. Okay. Sometimes open math is a little picky about the form you give things. Okay. You give them the right answer and they say it's wrong because the guy that programmed, and these are all programmed by volunteers. Okay. You know, programs and problems. And they do a pretty good job. Okay. Actually, a very good job. Almost all of them are very meticulous. Some of them, we both do. Okay. Again, my point is, do your own checking, especially if you think you're right and open math says you're wrong. Check your solution. If you're not completely sure your solution, check it for practice. If you're on a test, check your solutions. If I see you checking your solutions, even if you got it wrong, I'm probably going to give you a little bit more partial credit than I would if you didn't. Now, if you're right, well, give you a little more respect, no more points. Okay. Okay. Now, do we kind of understand how this is done? I don't want to slow people down. You know what they're doing. And you see this before, because there's some of you know this, but I'm going to give you one more like this, and then we'll go on to just see. You can follow the procedure. See if you can imitate the procedure I used. You don't have to write out this stuff as long as you are getting things right. Okay. See if we can work this problem. Okay. Doing okay still. A couple little questions. First of all, if 4x minus 3 is -8. What do I have to add or subtract to get rid of that 3? Well, I'm going to have to add, because -3 and 3 gives me 0. Okay. And that gives me 4x equals what's -8 and 3. Now, it's easy to make mistakes with sign numbers, so let me demonstrate. Here's a number line, here's 0. Okay. And let's say 1 is here. There's -3. That's our, where's -8? Well, -8 is 8 units to the left. Now, if a unit is this big, I go 1, 2, 3, 4, 5, 6, 7, 8 units to the left, and here's negative 8. Okay. And if you're not familiar with this, let me know. Email me or say so, ask me. And I'll give you some references on adding signed numbers. It's something you can Google and get plenty of videos and stuff. And it's not difficult. You've seen it. But if you're not good with adding signed numbers, if you don't understand what I'm telling you, you really want to get familiar with it. And I don't think it'll take you 15 or 20 minutes to get the right stuff. Okay, so we've got negative 8 here. Okay, now we can represent negative 8 by an arrow from 0 to negative 8. So that's like here's negative 8. That arrow represents negative 8. It's going in the negative direction. It's a negative number. Okay. And then first plus 3. Well, there's 1, there's 2, there's 3. So there's negative 8, and here is plus 3. Now, if we move over negative 8, and then we do plus 3, that means we've got to move over 8 units and then come back 3 units. Okay, so we've got like negative 8, and then we've got plus 3. And that leaves us here, which is 3, negative 5, right? So negative 8 plus 3 equals negative 5. Negative 8 plus 3 equals negative 5. Okay. Here's another example. Here's 0. Here's 1. Let's do negative 8 and negative 3. Okay. Well, if you put these arrows together, you get negative 8 here, and then you go negative 3 more. Go far enough. Okay. So the negative 8 and the negative 3 go together, give you what? Well, that's negative 11. You can count. There are rules for it. Okay. So if you have this picture, you understand how to add positive and negative numbers. Okay. You just add the arrows. But there's a little more to it, and we don't have time to go through it in this course. But there's plenty of stuff online, and I don't think anybody's going to have any trouble picking it up. Okay, so anyhow, negative 8 and 3 is negative 5. And then we do 4x over 4 equals negative 5 over 4. So we get x equals negative 5 over 4. And then we plug that back in here. If we multiply negative 5 over 4 by 4, we get negative 5, and negative 5 minus 3 is negative 8. And it checks. We're not going to write that out. Okay. Make sense? So make sure we understand these steps and do them meticulously. Of course, open math is going to give you videos and explanations, and you got, you know, written information, all kinds of stuff. And if you don't like the way open math explains it, look up solving linear equations. Okay? Do that, see what you got. But I tell you what, it'll probably be right, but don't ever trust it. It might tell you that negative 8 plus 3 is 42. Sometimes it makes up numbers. Okay. Okay. The second problem. I'm going to do it with the Okay, second problem was of 3 times 2x minus 7 equals 4 times 5x plus 3. Okay. Well, now we've got something new here. We've got a couple of new things, and this is kind of a jump from this. Okay. Now you have a couple of assignments. Let me make sure I'm telling you right. Because 2 courses, the distance and the in-class course, have slightly different order of assignments early, but I think we all catch up by next time. Yeah. So by next week, we've got to have done quite a bit with linear equations, so I really do need to address all this. Okay. Again, this is kind of a jump. It's not too hard to understand though. If I've got 3 multiplied by 2x minus 7 in parentheses, that means I've got to multiply 2x by 3, and I've got to multiply negative 7 by 3. Okay? So we would write this out as 3 times 2x minus 3 times 7. That makes sense? Okay. And then you've got to do 4 times 5x. And 4 times 3. So there it is, 4 times 5x, 4 times 3 plus 2. Okay. Now, if you've done linear equations, or some people have worked quite a bit ahead in this course and have already seen this, sorry if we're bored, but we'll try to be as entertaining as we can. If you can skip writing this step reliably, go ahead and do it. If you find you're not always getting the right answer, you probably ought to reinforce the distributive law, but a lot of people understand it. Still, if you made any mistakes, other than maybe a simple arithmetic mistake with either of these problems, and if it didn't check, you probably ought to do all the steps just to reinforce it. And then use your own good judgment when you stop doing any steps. Okay. 3 times 2x is 6x. 3 times 7 is 21. 4 times 5x is 20x. 4 times 3 is 12. We got 14. You can do that safely. If you're not absolutely sure, write it all out. Doesn't take long. Okay. Now what do you do now? Okay. Well, you got 6x minus 21, so yeah. Okay, let's take 21 equals 21. And I'll put the 21 over here, because it's a good idea to put numbers under numbers and not under coefficients. But it will give you an equivalent equation. Okay. Because 20x isn't equal to 20. Unless x happens to be 1. If x is 1, I don't think you've got a solution. Okay, so anyway, line up numbers with numbers and x's with x's. So this is going to give us 6x, because negative 20 minus 21 is 0. And this is going to give us 20x, because we're adding a number, not a multiple of x. And then we get 35. Okay. And with a little practice, it's really easy to get from here to, well, from here to here. Okay. And then once you're here, you probably see that, well, we want to add 21 to both sides, because now we have just x's on this side, right? However, we've got x's over here too. We need all of our x's on the left-hand side. And the way we do that is we then say, okay, well, I'm going to take negative 20x equals negative 20x, and I'm going to add these two equations. Okay? And 6x and negative 20x, well, 6 and negative 20 is negative 14. That's negative 14x. And 20x minus 20x is 0, and now we get 35. So x is 5.5. Oh, it's right 2.5. Okay. But you work that out in those. Now we're on familiar territory, just like we were here. We divide both sides by the negative 14. Then the negative 14 divides the negative 14 because this is the denominator, this is a coefficient of the numerator, factor of the numerator. And 35 over negative 14 is negative 35 over 14, which equals, because 35 and 14 are both multiples of 7, they do prime factorization divide out each prize, but that's going to give us negative 5 over 2, which is negative 2.5. Or the number line. That's what I do for. Make sense? Now, if you can do that much, then that should take you through most of the solving of linear equations. Okay, which is the main thing between now and now, since we've missed some classes, it's possible if people are having a lot of trouble with this, that we take an extra day on it and move some of the assignments back, because I've got room in the schedule where we can, in case of closures and emergencies, we can adjust the schedule. Okay, but do your best to get it, because right now we're working on elementary algebra, not intermediate algebra. And we got to get through the elementary algebra as quickly as we can so that we can do intermediate algebra. Okay, so please work hard on this. Okay. Take this equation, x over 3 plus 7 over 5 equals 3x. Now I'm just going to tell you what to do. I want you to multiply every term by 15. When I say multiply by 15, I mean multiply each term by 15. So just put a 15 times in front of each term. Or multiply both sides by 15. Okay, let's see what you've got. Yeah. Okay, see what it goes. One thing that I talked about is realizing this should go to the next. This is something you think I'm right? Okay. make it coherent, because I had trouble understanding what I was seeing. And I think if you're reviewed for tests, you're gonna have trouble understanding this, even though you're gonna understand it. If it's something you weren't completely sure of. So, that's good.
Just this, but.
Yeah, I'm gonna write it out. I could have stated it better, so I will in a minute. Okay, yeah, you're kind of skipping stuff, but that's right. Okay, let me explain what I mean here now. I might have stated it a little too briefly. Said multiply every term by 15. Well, not everybody understands the term. Okay? And some people went a little too far multiplying by 15. Okay? So I'm going to say we multiply both sides by 15, okay? Which is probably what I should have said in the first place. So if we do that, we just do this. And right there, it's very clear that this side is here and it's multiplied by 15. This side is here and it's multiplied by 15. Okay? So that's a step you probably shouldn't skip. Okay? And then what do? We multiply this by 15 and we multiply this by 15. Now, I see some people multiplying this by 15 and just writing down 5x without the intermediate step. Well, that's right. And it's so good that that's right that you can probably get away with that. But let's just write out every step just to be sure. Because you get down to the end and find that the check doesn't work, you want to be able to go back and test every little detail. Okay? So we want to write out all the details. We're going to write out 15 times x over 3 plus 15 times 7 over 5 equals 15 times 3x. Now, since x over 3 is a fraction, 15 is the same as 15 over 1. Okay? If you're a little fuzzy in multiplication of fractions, there is, I think, a later assignment on multiplication of fractions. You might want to skip ahead and do that just to make sure you've got it. It's something I kind of assume everybody knows how to do. And if I'm wrong about that, well, you can fix it easy. It's easy. Multiplying fractions is easy. Okay, so how do you multiply fractions? You multiply numerator times numerator and denominator times denominator. That gives you 15x over 3. Okay? 15 times 7 is 105. And 1 times 5 is 5. And then 15 times 3x is 45x. 15 times 3 is 45. Okay? Make sense? Now, all you have to do is divide 3 into 15, and then divide 5 into 105. And you've got an equation that looks a lot like this. Okay? Except you got x's on both sides. So, didn't leave myself a lot of room. So I have to write it pretty small. But 3 into 15 is 5, so that gives me 5x. 105 divided by 3 is 35. Make sure you see the x there equals 45x. So by magic, I've taken this equation with fractions and cleared them all out. Now I've got a very simple equation. Not totally simple because you got x's on both sides, but by the time you get through a couple of these assignments, you'll handle that in short order. Okay? So let me stop for a second. I've got a question. That usually means I screwed something up. So let's make sure I've got everything right, because we haven't checked this problem happened. Okay, now see, I pretended to make a mistake. And somebody called me on it. 3 into 105 is 35. Okay, I just looked at how 105 breaks down. I didn't even pay attention. In fact, this is 5. Okay, should have done a prime factorization. But 5 into 105 is 21, not 35. So now, if I had completed this thing and checked back and done everything even more meticulously, I'd have probably written down a prime factorization of 105. Okay, which is 3 times 5 times 7. Okay, and then I'd say that the 5 would divide the 5, leaving me 3 times 7, which is 21. I'd have just known, because I know if I really look at what I'm doing, that 5 goes into 120 times, and then there's 5 another, which gives me 21. So one way or another, I do recommend that you do as much of your arithmetic yourself as you can. Okay, if you end up with huge numbers here that you can't easily divide, 729 over 27, okay, which is just 27. But you wouldn't necessarily know that, okay? You would probably use a calculator. Then you'd be surprised it came out to the same. But it does. I think, you remember control. She would know. Yeah. Okay. Okay, so do you understand the trick here? And the bottom line is, and I'll repeat it, I'll probably write it out at some point soon. And there's just a little more time. When you got denominators, get the heck rid of them. You can't do it if you're adding fractions. You got to use a common denominator, you're going to get a fraction, right? But you can do it when you have an equation, because you can multiply both sides by something that'll clear out all of your denominators. Okay. And that would be the common denominator of 3, 5, which would be 13. Okay, okay, we've got time to do one more problem. Let's see how people do in here. I'll leave this up here because it's kind of new. Try this. We've got about 4 minutes. Let's see how far everybody can get. And then it's between you and open math in the video. Okay. And of course, you can always email me. Okay, some people are going to need the practice in this, and open math is going to give you plenty of practice. Let's go ahead and work out this one minute problem. Okay, this is going to give me 4 times 3x minus 4 times 2. Okay. This is going to give you negative 2 times 5x plus negative 2 times 7. Okay. And you get used to this. You'll have practice with the distributive law, and it won't take you long to get it because you're already getting it. Okay. And that gives us 12x minus 8 equals negative 10x minus 14. That multiplication ought to be straightforward. Then we're going to add 14. Add the equation 14 equals 14. Yeah, I guess. What am I doing? I didn't do that. But add 8 both sides. We're gonna get 12x equals negative 10x minus 6. Then we're gonna subtract 10x from both sides. Add 10x from both sides. That'll give us 22x equals negative 6. And then we're going to divide both sides by 22. Then we get x equals negative 6 over 22, which is negative 3 over 11. Now, if I plug that in here, I get negative 9 over 11. And adding that to negative 2 gets something close to negative 12 on this side. Now I'm just doing an approximation. I do all the arithmetic. It'll take me a little longer and we're out of time. That'll give you some kind of close to negative 5. Negative 2 times negative 7 times 2 is 4. What did I get over here? I'm not sure that's right. So let's see, what could I have done wrong? Well, we'll have to figure it out. But you wrote things out right here. What you do, you should be home free. Okay. 14 and 6. Yeah, I made a mistake. I think it's more likely to be in my chat. Oh, it's negative 3 over 11. It's negative 3 over 11. So that'd be like negative 2, 7. Yeah, I think it checks. Okay. But checking it with a fraction is a little complicated. I could do it in my head, but it could get a little slow and unreliable. Okay, so you can check it out, but there's a process. Okay. If you made a mistake and can't find it, I'd be glad to take a quick look at it.